Welcome to a video on multiplying and dividing by 10, 100 and 1000. I use a method which I call the moving method for this. It's different to our standard methods for multiplying and dividing. That's a very important thing. You need a different method for these questions really. So let's start looking at it with times. Now if we look at a normal times question, or the most common kind of multiplication question, is something like this, isn't it? And the method you use for this is of course your column method. 345 times 5. Okay, now this is not what today's lesson's about, but I'm just reminding you of your standard method for most multiplication. You're going to use that. But with times, what you need to do when you see that you're doing a times question, you need to think for a minute. Is it going to be your standard method, or might it be a different method? Because there's two other methods that come up a lot. For example, this question, 40 times 30. I would not waste time doing the standard method for this, because it's 4 times 3 in disguise, isn't it? This is what I call times tables in disguise. 4 times 3 is 12, and there's 2 zeros in the question. So 2 zeros on the answer, 1,200. So sometimes you might want to do a times tables in disguise method instead of your standard method. So we've seen this method, and we've seen, well, this one, which is not really a method, it's just writing the answer by looking at the question. But moving method is something else. It's a third method. And this is the important thing. A lot of people will see a question which features times 10, times 100, or times 1000, such as this. They'll see this question and they just don't think about which method to use. They normally automatically just go to this method. And when you go to this method for a question like number 3, it either takes much longer than it needs to, or it goes wrong. So a lot of people get this wrong doing this on the standard method. Very easily does go wrong on the standard method. All you actually need to do for question 3 is what I called a moving method. So you don't really need to do much. If there's a decimal point, you just line one up underneath. Okay? When you multiply by 100, multiply makes things bigger. So we're just going to move the digits, just going to move these 3 digits bigger. We're going to make them bigger. This way is where things get bigger, isn't it? Away from the decimal end. The decimal end is small, this way is big. So we're going to make the digits bigger. 2 zeros on the 100 means we're going to move the digits 2 places bigger. So this 2, instead of going in the same column and being worth the same, it actually moves 1, 2 columns bigger. The 3, instead of being worth the same, it moves 2 columns bigger because of the 2 zeros. And the 6 moves 2 columns bigger because of the 2 zeros. If there's any gaps, you fill them up with zeros. So that's the moving method. 23.6 times, whoa, excuse me, 23.6 times 100 is 2,360. And that's our answer. So you see how you don't need to do the standard method like this. All you've really done is move the digits underneath the original. Okay. The biggest problems with this method are people doing the standard method instead of doing the moving method on a question like this. And the other one is just inaccuracies. I've never seen something in maths that people get so wrong, even when they know how to do it, because people just think it's too easy and rush it. Let's do a little bit of practice of the moving method for times. When do you do the moving method? When you see this, or this, or this, or even times 10,000, but you won't see that very often. So we focus on these 3. It's when you see these zeros on the end, a 1 and some zeros really, that you want to do the moving method. So let's do some examples. 35.84 times 10. Now a lot of people say that when you times something by 10, you just put a 0 on the end. And that actually works, but it doesn't work when you're using decimals. So it doesn't work on this question. If you just put a 0 on the end of this question, you haven't actually changed the value of the number. You definitely haven't made it 10 times bigger. So it doesn't work. So it isn't just putting a 0 on the end. What you do with the moving method is line up the decimal point if there is one. You know we're timesing by 10, multiplying by 10, so there's 1 0, so we move everything 1 place bigger. The 3 doesn't go underneath, it goes 1 place bigger. Then the 5, then the 8, then the 4. See how every digit is still in the same order, 3584, 3584, but they've they've moved bigger. They've got bigger because they've moved that side of the decimal point towards the big end of the numbers, because times makes things bigger, doesn't it? So that's the moving method. Let's call that question 1. And we'll do a question 2, which is multiplied by 100 next. So question 2, I'm going to multiply something by 100. Let's say there's no decimal point on this one. This one's not too hard. You might well know the answer straight away anyway, but I want to show you how the moving method will work for it. So if there's no decimal point, where does it go? At the end. That's something you should know in maths. If there's no decimal point, where does it go? At the end. 537 is the same as 537 point nothing. Then you can line up a decimal point. Now we've got to move everything 2 places bigger because there's 2 zeros. So the 5 goes 1, 2 places bigger. So does the 3, and so does the 7. Now the good thing about putting that decimal point there is it tells you where to stop adding zeros. I mean placing zeros. It tells you where to stop placing zeros. So the answer is 53,700. That was one without a decimal point. Let's do question 3. We'll multiply something by 1,000 on the last one. Let's do purple. So we'll get a decimal back for these ones. The decimals are normally the hardest ones. So it already has a decimal point in it now. Remember, you can't have more than one decimal point in a number. So this is a moving method. Put a decimal point underneath, and we're going to move these digits, 7, 8, 7, 4. They'll still be in the same order, but they're going to get bigger, because times makes things bigger usually. How many places bigger? 1, 2, 3 places bigger. So the 7 goes 1, 2, 3. Sometimes you'll crash into the margin of your book when you're doing these questions. After a lot of time, you start to learn how to set them out so you don't crash into things. But that's going to happen a lot at first. I crashed into almost my question number. I was lucky that it was not one more place bigger. So everything's got 3 places bigger, and we get 7,874. Okay? So just to recap, on the first question, when we times by 10, there's 1 0, so everything got 1 place bigger. When we times by 100, 2 zeros, so everything gets 2 places bigger. When we times by 1,000, 3 zeros, so everything gets 3 places bigger. And that's the moving method. I'm going to do one more for times, because the moving method should also be used, and this is where people don't always spot it, when the 100 or the 1,000 or the 10 is at the start, at the front of the question. Something like this. Because this is still moving method. All I'm going to do is I'm going to times this by 100. So I'm going to write my answer underneath this part. Because it's still times 100, isn't it? Doesn't matter what order the question's in on times. It's still going to be moving method if you see a 1 and some zeros. So 100 is 2 places bigger. 5 goes 1, 2 places bigger. 4 goes 2 places bigger. 7 goes 2 places bigger. You see why I do the decimal point? Because it tells you where to stop placing zeros. Because you fill in the gaps up to the decimal point. 5,470 we get. So that was moving method 4 times. You've got to choose your method. You've got to think, is it standard method? Is it times tables in disguise? Or is it moving method? And you've got to think that on every times question, so you don't end up doing the wrong method, wasting loads of time, maybe getting it wrong. With divide, we have similar choices, don't you? Our standard method for division is the bus stop, isn't it? Where we do something like this. We'll do a bus stop. Can I fit it in over here? Let's fit it in over here. You can get very fast at bus stops, of course, with a lot of practice. And I advise you to have a lot of practice. So that's one method we might use for division. But there's other methods, so you don't always want to do the bus stop. You can have division facts in disguise. 180 divided by 6. You could just do this on the bus stop, no problem at all. Or you could say it's 18 divided by 6 is 3, and a 0 from the question. Division facts in disguise can get more complicated than this. It can. But that's okay for now. We're not really doing that. We're not doing that at this lesson. We're doing the moving method, which I'll do for number 3. So on division, when you see divide, you've got to think, do I do standard method? Do I maybe do division facts in disguise, if you can see that this is 18 divided by 6 in disguise? Or do you need to do moving method on a question like this? 56.8 divided by 100. So how do you know it's moving method? How do you know? It's when you see divided by 10 or divided by 100 or divided by 1,000. When you see that, you've got to think moving method, not a different method. So I'll do the moving method. But as you know, divide, as I'm always saying, usually makes things smaller. Usually. So now we're going to have to move the number, but we're going to make it get smaller as we move it. So we're going to go towards the decimal end of the number where the small bits are. Decimals are small bits, aren't they? So we're going to move it towards the small end of the number. 2 zeros means 2 places. The 5 goes 1, 2 places smaller. 6 goes 1, 2 places smaller. The 8 goes 1, 2 places smaller. We get 0.568, which is 0.568, isn't it? And that is the moving method for division. Again, you've got to choose the right method. If you see this, divided by 10, divided by 100, divided by 1,000, you know it's moving method. Let's do 3 examples of this. So we'll do divided by 10. Let's just do 36 divided by 10. As I always say, if there's no decimal point, where does it go? At the end. Put 1 on the end. We're dividing by 10. 1 0, so 1 place smaller for the 36, the 3 and the 6. So the 3 doesn't go underneath because that would just be the same. It gets 1 place smaller. So does the 6, and we get 3.6. The decimal point is nicely in the right place because I put it in at the start, didn't I? Let's move that up so I can fit 2 more questions on. Question 2. Let's do 4,500 divided by 100. Moving method. If there's no decimal point, where does it go? At the end. Line 1 up underneath. So the decimal's in the right place. Divided by 100 is 2 places smaller, because divide makes things smaller. The 4 goes 1, 2, right over here. The 5 goes 1, 2 over here. You could put the zeros on as well, but it's 45 anyway, isn't it? 45 point nothing, or 45 point nothing, nothing is still 45. So the answer is 45. And on to question 3. We've got to divide 1 by 1,000. Let's do 7 divided by 1,000. Division makes things smaller usually. 3 places smaller. If there's no decimal point, put 1 on the end. Then we can line the decimal point up. We've got to make it 3 places smaller. So the 7 doesn't go in the same place. It goes 1, 2, 3 places smaller. Now I've put the decimal point there. Any gaps now on the right need to be filled in with zeros. 0.007, that's a very small number. It's the same as 0.007. So there is the moving method for division. I think I said this already, I don't know if I did. I don't see anything in maths that people make so many mistakes on as the moving method. A lot of people think it's too easy, they rush it, they move it the wrong number of places, they move it the wrong way. You've got to remember times makes things bigger, divide makes things smaller usually. And you've got to make sure you do the moving method when it's a moving method question, which is when you see this. When you see something with this in, these six things at the top, then you need to do moving method. Just keep practicing. Practice makes you better. I'll see you again.